In this demo, we're going to talk about the segments in Postgres, and when the table size increases beyond 1 gigabyte, how an additional segment is created. For example, let's say your table size is 4.5 gigabytes. There might be 5 segments created. Let's see how this works in Postgres. This diagram is an example of a rel file node. As you can see, we are looking at file 65485. Within this, we have 65485.1, point 2, and point 3, like so. As you can see, by default, it's 1 gigabyte. However, each time we go over 1 gigabyte, an additional file is created. Now let's move ahead with the demo and take a look at a table that's below 1 gigabyte and load some data into it and see what happens when the size increases. Here we'll be referring to a table called PG Bench Accounts. Now let's see what the size is. So if we use DT+, we can see PG Bench Accounts is currently 13 megabytes, under the 1 gigabyte threshold. From here we will retrieve the rel file path. So with this, we can now see that the base is the main folder, the second is the DB OID, and the third is the rel file node. As you can see, there is only one file right now. We also have these two, free space map and visibility map, which we will discuss later. For now, we'll just ignore these. Now that we know PG Bench Accounts is only 13 megabytes, below 1 gigabyte, what we're going to do is we're going to drop these tables and recreate them with a larger table and see what happens then. Now that we've dropped all the PG Bench tables, what we're going to do is reinitialize with a bigger size. You can specify the scaling factor here. Here we're specifying 200, which will create a bigger table, around 2.5 gigabytes or so. Let's run this and let it populate. We can see here it's trying to load the data into the table. Once it's done, we can check the size of this table. If you remember earlier, it was around 13 megabytes. Now once we load this data with a higher scaling factor, it will be around 2.5 gigabytes, and we'll see how many segments are created in the background now that the size has exceeded 1 gigabyte. Here the load is done, and we can see how many tuples were inserted. Let's check the size of the tables now. As you can see, the size of this table has changed to almost 2.5 gigabytes, where earlier was under 1 gig. We saw only one segment was created at that time. Let's look now. After retrieving the rel file path, we can see that the ls command is now the same, replacing the rel file node. You can see we have 3 segments now, where earlier there was only one, because the table size was below 1 gigabyte. Now we're sitting at around 2.5 gigabytes, so as you can see there are 3 segments. The first one is around 1 gigabyte, the second one is another gigabyte, and the third would be whatever is remaining. If we were to go beyond 3 gigabytes again, a fourth segment would be created. You need to remember that by default, the segment size is around 1 gigabyte. So if you're working with a large table that has around 100 gigabytes, you'll have a lot of segments. Keep this in mind.